Hello, warriors. This is Miss Lemons, and today I'm going to be walking you through at least the first page of the Introduction to Ionic Solubility and Molarity worksheet. Now, I am going to be annotating this paragraph up top, so make sure that you have a pencil and a highlighter ready to go, and you are also making those same annotations in your text. All right, so in Unit 5, we learned a simple rule about the solubility of molecular compounds. Okay, so first I see molecular compounds. I'm going to go ahead and just put a little bit of extra information there. So I know that molecular compounds, two nonmetals, and that's when the electrons are shared in a covalent bond. So a simple rule about the solubility of molecular compounds. Like dissolves like. All right, little bit of review. Like dissolves like is referring to those IMFs. Oops. Those IMFs. So substances with identical IMFs are able to dissolve each other. So like IMFs dissolve like IMFs. Okay. Unfortunately, the solubility rules for ionic compounds are not as simple. All right, so I'm seeing ionic compounds. This is another review. Ionic compounds are a little different. They are made up of ions. The cations are either metals or polyatomics. The anions are nonmetals or polyatomics. And when they are chemically combined, they are neutral in charge. In this activity, we will practice using the solubility rules for ionic compounds, which, by the way, you can find these rules on page 4 of your packets. Determine which compounds are soluble or insoluble in water. This activity will also help us understand what happens to an ionic compound when it dissolves and how changing the amount of solute and or solvent impacts the molarity of a solution. Molarity is how we measure concentration, and we are going to be talking about this more later, but I'm going to go ahead and just put a little note there so I know what molarity is as I go through this activity. Okay, so let's start by looking at the vocab. So I'm actually not going to spend any time on the vocabulary. As you can see, I've provided you the hyperlink to the vocabulary list for Unit 7. You can also access that on the website. So be sure to take a look at that website vocab list in case you're not familiar with any of these terms. We were briefly introduced to them in Unit 5, but you might need to brush up on them a bit. Let's move on here. When thinking about an ionic compound's solubility, we will always assume that water is the solvent, and I'm going to go ahead and highlight that. When an ionic compound dissolves in water, the solvent, we will call it an aqueous solution. So if we look at the word aqueous, we can kind of see the word aqua in there. So I'm going to just put a little note to myself here that aqua is like water, and so an aqueous solution is a solution where water is the solvent. So how will we know if an ionic compound is soluble in water? We're going to do that by following the solubility rules for ionic compounds. That's on page 4 of your packets. Let's practice by determining if the following compounds are soluble or insoluble in water. Now, I've already gone ahead and I've copied over all of the solubility rules. You do not need to memorize these. You just need to know how to use them. So first, when you're looking at the compounds, you really want to make sure that you have the name, or you're at least familiar with what the name of this compound could be. So it's important that you brush up on your ionic compound nomenclature in order to use these solubility rules. Let me show you why. If we were to look at the compound lithium chloride, you want to consider both the cation and the anion when looking at the ionic solubility rules. So let's first look at lithium, the cation. All right, rule 1, all compounds containing group 1A metals are soluble. All right, so let's take a look at the periodic table here to see if lithium is in group 1A. Okay, so lithium is in group 1A, so we know that lithium is going to make this a soluble compound. But I don't want to just stop at lithium. I also want to make sure I take a look at chloride just in case there isn't an exception to this rule. So let's scan through the other rules until we find the word chloride. All compounds containing ammonium ion, nope. All compounds containing the nitrate, chlorate, or perchlorate ion, nope. And we know that those are polyatomics anyway because they have 8 ending. Most compounds containing hydroxide are insoluble. Barium hydroxide, calcium. Nope, that's not what I have. Number 5 says most compounds containing the chloride, bromide, iodide ions are soluble. Okay, so looking at this, most compounds containing chloride, bromide, or iodide, I do have chloride here, lithium chloride. So not only does rule number 1 tell us that this is soluble, but also rule number 5 also tells us that this is soluble. Okay, so we would put an X in soluble and not in insoluble. Let's take a look at ammonium sulfate. Again, I'm going to look at both my cation and my anion. Ammonium, let's see if it's ammonium, all containing group 1A metals. Well, I know ammonium is a polyatomic, so it's not going to be in group 1A. All compounds containing the ammonium ion are soluble. Oh, cool. So rule 2 says that all compounds containing ammonium are soluble. Let's go ahead and just see if there's anything for sulfate in here. Rule number 3, perchlorate, nitrate, and chlorate. Nope. Number 4, containing the hydroxide ion. Nope. Number 5, containing chloride, bromide, or iodide. Nope. I'm looking for sulfate. Number 6, all compounds containing carbonate, phosphate, sulfide, chromate, or dichromate. Darn it, that's not it either. And then most compounds containing the sulfate ion are soluble. It's important to keep reading though, just in case. It says calcium sulfate and silver sulfate are slightly soluble, and barium sulfate, mercury 2 sulfate, and lead sulfate are insoluble. Okay, so those exceptions don't apply to ammonium sulfate. So rules 2 and 7 actually confirm that ammonium sulfate is soluble. So for these other compounds, you should probably write down the names of these compounds because you can see that we use the names here in the rules. But otherwise, that's how you use the solubility rules. You don't have to memorize them. You just need to know how to apply them. Good luck.